Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamed HAKIM Ahmad. So I will start with a problem description of our assignment presentations. So a cantilever beam strength as a structure is determined using the von Mises stress analysis. This beam, which is supported at one end and is free at the other, is exposed to external loads that cause internal stresses. The analysis calculates the von Mises stress distribution, which shows the equivalent stress that can result in failure, considering both tensile and compressive stresses. The problem at hand is to determine the normal and shearing stress values at point A, B, D, and E within a given structural component. These points are of particular interest as they correspond to critical locations where stress concentrations or load transfer occur.
Assalamualaikum and hi, my name is Ahmad Farid bin Mohamed and my matric number is B092010027. Now let's talk about the procedure of making the I-shaped beam or meshing. So the step number 1 is set the preference, which is to structural, and then the next step is define material properties, which is we need to select the solid and then break at knot 185. Step number 3 is define element types and option, which is we need to select the structural, linear, elastic and isotrophic, and then we need to insert the perimeter of the beam, which is the Young modulus is 205 gigapascal, and then the Poisson ratio is 0.27. And then the next step is define and or create the block according to the dimension given. Okay, so step number 5 is combine the 5 block using glue. So we need to select all 5 block to combine to produce the I-shaped beam model. And then the final step is step number 6 is meshing the I-shaped beam model. So we need to divide the element into 10 or 9 element. The boundary condition. So the first observation is the maximum displacement, which is the form shape. So the maximum displacement of the beam is 0.597 exponential negative 3. The second observation is the maximum stress, which is von Mises stress. So the maximum stress of the beam is 169.111 megapascal. The third observation is the maximum shear stress, which is SY shear stress. So the maximum shear stress of the beam is 78.4482 megapascal. The normal stress at each point. So the point E is 83.3147 megapascal. Meanwhile, for the point B is 59.0541 megapascal. The point D is 45.2625 megapascal, and then lastly point E is 12.603 megapascal. Meanwhile, for the shear stress at each point, point A is 0.118456 megapascal. For point B, negative 0.0533469 megapascal. Point D is 0.153461 megapascal, and finally for the point E is negative 0.046342 megapascal.
My name is ULFA SYAZWIN binti Mohamed SAHABUDIN. My matrix number is P0920104112. I will explain the result value by question. The results are from normal and shearing stress at point A, B, D, and E, maximum stress, maximum displacement, and also safety factor. The value for normal and shearing stress at point A, B, D, and E are shown at the table below. For point A, we get 86.498 megapascal and 0. For point B, we get 56.994 megapascal and 9.472 megapascal. For point D, we get 42.242 megapascal and also 2.834 megapascal. For point E, we get 12.738 megapascal and 0. For maximum stress, we get 99.237 megapascal. maximum displacement 12.2 exponent negative 6 mm, and lastly safety factor 2.52. This is result value comparison with theory. For result value theory, I already explained at the previous slide. I will explain the result value for NC simulation. For normal ensurance stress at point A, B, D, and E. For point A, we get 83.3147 megapascal and 0.118456 megapascal. At point B, we get 59.0541 megapascal and negative 0.0533469 megapascal. At point D, we get 45.2625 megapascal and 0.153461 megapascal. And lastly, at point E, we get 12.603 megapascal and negative 0.0463642 megapascal. For maximum stress, we get 169.111 megapascal, and lastly, maximum displacement, we get negative 597 exponent negative 3 millimeter. This is the percentage of error. For normal stress, the maximum that we get is 7.15%, while the minimum we get 1.06%. For shear stress, the maximum that we get is 100.56% and the minimum is undefined. This is because due to mistake while conducting the NC simulation and also calculating the theoretical calculation. Next, maximum stress is 70.26% and lastly, maximum displacement is undefined. This is also due to conducting NC simulation and theoretical calculation.
So for the last topic, to improving the accuracy of machine result in NCs can be achieved through several strategies. So there is some improvement in the accuracy of machine analysis result that can be considered. So for the first one is mesh refinement. Second, high order element usage. Third, element shape quality consideration. Next, mesh validation, and then adaptive meshing technique utilization, and last experimental data or analytical solution verification. So by combining these strategies, engineers can enhance the accuracy of meshing in NCs, leading to more reliable and precise analysis result. That's all from us. Thank you.